Have you ever wondered what makes a jet engine tick and how it manages to propel a massive airplane through the air? It's a question that has puzzled many, and the answer lies in a clever combination of air, fuel, and spinning parts. Think of it like a super powerful fan, where air is drawn in at the front, mixed with fuel, and then ignited, producing a hot gas that expands rapidly and shoots out of the back, creating a forward force. But that's a big simplification. In reality, a jet engine is made up of many intricate components, working together in harmony to generate an incredible amount of power. And here's the surprising part. The basic principles of a jet engine are not so different from those of a car engine, with a similar four-stage process of intake, compression, combustion, and exhaust. The key difference, of course, is the scale and the fact that a jet engine is designed to produce a huge amount of thrust rather than just turning wheels. So let's dive in and explore the inner workings of a jet engine and see how it all comes together to make air travel possible. And by the end of this video, you'll have a much better understanding of what makes these incredible machines tick. So be sure to keep watching to learn more about the fascinating world of jet engines. And don't forget to subscribe for more explanatory content vocabulary. Propulsion, intricate combustion, exhaust. All right, let's dive into the basics of how a jet engine works. At its core, you can think of a jet engine as being a bit like a super powerful balloon that never stops inflating and deflating. Here's what happens in simple steps. 1. Air intake. First, the engine sucks in air. Imagine sticking your hand out a window on a windy day. Air rushes into your palm. That's exactly what the jet engine does, but on a much larger scale. 2. Compressor. Once inside, that air is forced into a compressor. Now, think of this like a supercharger on a car. Just as it squeezes the air to make more power in an engine, the compressor squeezes the air to increase its pressure. 3. Turbine and fuel mix. The compressed air then flows into the combustion chamber where it meets with fuel, igniting a fiery mix. This is like lighting a candle. When you light a match, it burns, producing heat and light. Here, the burning produces incredibly hot gases. 4. Expanding gases. These hot gases expand rapidly as they rush through the turbine. It's similar to blowing up a balloon and then letting the air out suddenly. It pushes back with force. In an engine, this push is what creates thrust, propelling the plane forward. Okay, so we've talked about how a jet engine works on a basic level. Now let's peel back that layer and look at the engine's four main components: the compressor, the combustion chamber, the turbine, and the nozzle. Each one plays a vital role in producing the incredible forces needed to propel an airplane forward. First up is the compressor. Think of it like a giant fan in your kitchen exhaust hood, but way cooler. Air comes into the front of the engine, hits this spinning fan, and gets pushed through the engine with increasing pressure. This high-pressure air then moves on to the next part, the combustion chamber. The combustion chamber is where all the action happens. Imagine you're lighting a match in an enclosed space. That's what we do here, but with much hotter flames and lots more fuel. The air from the compressor gets mixed with fuel, and when it's ignited, it explodes into fiery, super hot gases. This is the part most people don't know. The gases are incredibly hot, up to thousands of degrees, but they're also incredibly fast-moving. Next comes the turbine. Here's the surprising part. This isn't just a passive component. It actually drives the compressor and keeps the engine running. Think of the turbine as the engine's power source, kind of like how your car's engine drives the wheels backward to keep everything spinning smoothly. The hot gases from the combustion chamber spin the turbine, which in turn spins the compressor, creating that never-ending cycle of air and heat. Finally, we have a nozzle. This is where all the energy gets released. Imagine you've just opened a water bottle with an inverted cap. The force builds up until it finally bursts out, creating a powerful stream. That's similar to what happens in the nozzle. The gases leaving the turbine get pushed through this narrow opening, and because of their high speed, they create a powerful backward push that propels the plane forward. Together, these four components work like a well-choreographed dance. Each step is essential for the engine to function and keep you flying safely up there in the skies. Isn't it amazing how something so complex can fit into your overhead compartment? Okay, so now you know about the four main components of a jet engine: air intakes, compressors, combustion chambers, and turbines. But how do these parts work together to actually generate thrust? Let's dive into that. Imagine blowing up a balloon and then quickly letting the air out. As the air rushes out, it creates a forward motion, right? That's exactly what happens in a jet engine, but on a much grander scale. When the hot gases from the combustion chamber exit through the nozzle, they expand incredibly rapidly. Think of it like a water hose. When you open the tap wide, the water comes out at high pressure and velocity. In our jet engine, this hot gas is expelled with even more force because of its incredible temperature and pressure. Now here's where it gets interesting. As these gases escape through the nozzle, they are moving at incredibly high speeds, up to several hundred miles per hour. This rapid movement creates a lower pressure area behind the engine. According to Newton's third law, for every action, there is an equal and opposite reaction. So, when the hot gases are pushed out of the back, they push the plane forward with a force called thrust. And just like how the wind can make your hair stand up or blow a leaf across the street, this force is what propels the aircraft through the sky. It's not magic. It's all about the physics of moving fluids and gases. So, every time you see a jet engine spewing out those hot gases, remember that it's harnessing the power to push your plane forward with tremendous thrust, making every flight safer and smoother than ever before. What makes jet engines so efficient and safe, despite their incredible power? The answer lies in their design, which prioritizes reliability and redundancy. Think of a jet engine like a high-performance sports car. It's built for speed and power, but also for safety and durability. And just like a car has multiple safety features, such as airbags and anti-lock brakes, a jet engine has multiple layers of protection built in to prevent failure. For example, jet engines have duplicate systems for critical components, like fuel pumps and control systems. So if one fails, the other can take over seamlessly. And here's the reassuring part. The chances of a jet engine failing are incredibly rare, thanks to rigorous testing, maintenance, and inspection schedules. In fact, the aviation industry has an impeccable safety record, with accident rates decreasing dramatically over the years. This is due in part to the stringent safety standards and regulations that govern the design, manufacture, and operation of jet engines. So, the next time you're on a flight, you can take comfort in knowing that the jet engines powering your plane are not only incredibly powerful, but also remarkably efficient and safe. And that's a reassuring thought, especially for nervous flyers. So, how does all this come together to make air travel so safe? That's what we'll explore in our final scene. Vocabulary: redundant, impeccable, rigorous, duplicate. So, to answer the question of how a jet engine actually works, it's a complex yet elegant process that relies on the clever combination of air, fuel, and spinning parts. Think of it like a perfectly choreographed dance, where every step, every move, and every component works together in harmony to generate the thrust that propels a plane forward. And here's the surprising part. This intricate process is not only powerful, but also remarkably efficient and safe. The next time you're on a plane, you can appreciate the incredible technology that's keeping you safe and sound, from the turbines that drive the engine to the sophisticated systems that monitor and control its performance. You might even find yourself listening to the hum of the engines in a new light, knowing the amazing science and engineering that's behind it. And if you want to learn more about the fascinating world of aviation, be sure to subscribe to our channel for more explanations and insights. If you'll never look at a plane the same way, you know what to do. Vocabulary: turbulence, propulsion, efficiency, aerodynamics.